Hi, Mr. Ray here. Today we're going to do the second video in our gyro navigation series. The program on the screen is the one we ended with the last time. This is a program that would drive the robot straight when you called it. Now, to be useful, it would need to be a my block. And when we make the my block, we're also going to make it so we can have the robot turn and then go straight. Let me shrink myself down to give a little room and we'll get started. Okay, so first, we want to separate the parts that are the program that actually does the drive straight. So we need all of these instructions except these two. And then we need to make these into a my block, and we'll add a few things to it. First thing I'll do is create the my block. So I'm going to make a block. I'm going to call it gyro nav. Space out here a little ways. I'll put in the label for the first input, and that will be angle. And then I'll add that angle. I think I'll call it turn angle. Then I'll add another label. Call this one speed. And then I want to add another label. And I'm going to call it motor rotation. And I need to add the input. And I'll just call it MROT. Now that's going to be my block. And so this will wind up as a header for this. Now let's talk about what it's going to do. So when I call this, the robot will turn through angle. Its final speed will be speed, and in this case, it will be told to go that immediately. And motor rotations will tell me how many motor rotations I want to travel. And in the way we implement it, it is either motor turns this many rotations. That will end this my block. So now I need a couple of new variables. Call one heading error. And call one heading demand. So now I have these two new variables that I'm going to use in a moment. Now let's talk about how this my block might work. I'm going to move it over just a little. So turn angle. Using the gyro, we can either use it like it is a compass, or we can use it to measure angles. In this case, this is going to be the angle I want to turn. It'd be very simple if you'd prefer to keep it the other way, and then this would become a heading demand, where you would demand a heading that was what the gyro would be pointing to at the end. So, but in this case, I'm going to make this a turn angle. It's a little easier to do some of the things you'll do building missions with an angle there. Okay, let's see how we want to use this. Well, first, here is where I specified the number of rotations that I wanted the robot to go in our previous file. Now I want to replace that with this number so that I can specify it when I use the my block. Okay, so now I'm ready to use the new variables I defined. So the first one is I want to compute the heading demand. The heading demand will be the current gyro angle plus this turn angle. So this will give me a new heading. Now you notice the heading demand is like a compass setting to the gyro, using the gyro, even though we're just using turn angle. So let me get an arithmetic block. So I want to add the turn angle to the current gyro sensor position. And it's on mine's on port 1, so I can change that. Now, that is the new heading I want relative to what the gyro is reading. So this will be more like the gyro is used as a compass, even though I'm specifying a turn angle. Okay, so now how are we going to use this? Well, next I need to calculate, down in here, I want to calculate, change this calculation, and I want to calculate a heading error that will tell me how many degrees I'm off of the heading that I want to go to. So let's get the variables, get another one of these, heading error. Now the heading error is going to be the difference between heading demand and the current gyro angle. So I need to get a minus operator. Whoops. And I want to subtract the current gyro angle from the heading demand. So we'll get the heading demand. And I'm going to just grab that right there. So heading demand minus this value, and then I want to get rid of this. And what I want to do is I want to get another heading error. So let's put this in and then we'll talk about it in a minute. So now I've computed the difference between the direction I want to go and the direction that the robot is currently going, and I use that as the error term, or the turn command here. That will turn the robot in the direction to make this difference go to 0. And I want to drive at a speed that I specified here. So I'll pull this down. And let's see. So we've used MROT, we've used speed, and we've used turn angle. Okay, we do not need that anymore. Get rid of some of these. Put this back up here. I am going to add another debugging tool or testing tool. I'm going to reset the timer. In Classroom, you only have one timer. LabVIEW, you had more than one. So this resets my timer to 0. We'll use that later along with count that we put in last time to test how fast this loop runs. And as we move further with some of the other additions we'll make to this program, we can keep checking and just make sure that we haven't made this repeat loop, run too slow. Okay, so I think that we have everything there. We do need to use it if we want to see it do something. And so I would stick it in here. Put all this back up here. And I'll just pick an angle like 45. And I think I'll use minus 45. It's easier to film. Minus 45. And I'll say 35. And we'll go 4. So I will move over to move the camera in a moment, and we'll take a look at this. Okay, so now I've got the robot set up. We've told it to turn at a, supposed to be minus 45 degree angle. I left the minus sign off, it looks like. Speed 35 for 4 rotations. So let's see what it does. All right, so you see that it did what it was supposed to. Okay, I want to show you something. So when I have it do a really large rotation, I want you to see how it turns. Now I'm going to slow it down so it doesn't happen quite so fast. Now I've told it to make a 3/4 of a revolution, minus 270 degrees to the left, and then go straight. So it should spin around until it's facing the camera and then drive probably into the wall. But let's see what happens. Okay, so what I wanted you to see is, you notice for this large turn, the robot basically did a point turn on itself. Probably the next video, we will modify this routine again so we have some control over what type of turn. So we could have made this do a pivot turn. We'll also add the capability to drive backwards. Remember that this one only works going forward. All right, that should do it for this time. Hope to see you next time. That is the end of this program, and if you want to see the remainder of the series, you can look in the Lego Classroom Navigation series on Ray's Robotics, and you can see all the videos that I've completed for this thing. So be sure and subscribe, and I'll look forward to seeing you the next time.